Hello everyone. Today let's solve the problem number 94 binary tree in order traversal. Right. So what the question states here, we are given the root of the binary tree. We have to return the in order traversal of its nodes values. So we have been just given the root of the binary tree. You can just clearly see here. We have been given root of the binary tree. We have to return the in order traversal of its nodes values. We have to traversal in order. We have to return the in order traversal of its nodes values. Right. So here in this case, let's go with the output here. Let's come to the example. Just give me a second here. 1 second. Yeah, we have the root 1 null. Just give me a second. What happened to this one? 1 second. So yeah, here we have been given this one. 1. This one is considered null. This one is considered 2. We have the value 2 and 3. Right. So we have to return the output in the form of in order traversal. Right. So here in this case, in order traversal falls this one. Follows the order left node and then right. Left node and then right means here if we have this one left, this is node and this is right. So usually we start with the left node always, right? Left, there is no node present at the left at all here for this one, right? So here in this case, let's go with the approach. First thing is we have to do this one. We have to return the output in the in order traversal, right? So by making use of in order traversal, that's what they have given in the question. So first we have one. We'll go with one here. This one because we don't have the node at left at all. Then we will consider 3, which is at the left of 2. Then this will be 2 basically, and then it will be 3, right? Then it will be 3. So the output will be 1 3 2, right? So this has to be 3. Sorry, left 3 we have. This has to be 2. So just give me a second here. The output here would be 1 3 2. 1 3 2. Because 1 we don't have left node at all. Next we will consider the left node here. So then the node we don't have right anything here. Let's ignore this one. This will be 1 3 2. 1 3 2 in order traversal, right? So let's move on with the second example here. So just give me a second here. Let's move on with the second example here. So 1 second. We have 1, 2, 3, 4, 5. This one 1, 2, 3, 4, 5. Here we'll consider this one null. Null 8. So this one again we'll consider null. Null 6, 7, 9. Right. So this is fine. The output that we need to get here is we have the left node here. So at this one we'll be considering the first node here, right? Deep, the last one. So this one will be 4 4. Then we have to consider node nothing but 2 4 comma 2. This one, right? Then we'll consider this one 4 2. Here for 5 we have the left node, we'll consider 6. Then we will go with the node 5. Then we will consider the right. This will be 7. And then we will consider the root of this one, entire one. This one will be 1. And this let's come to the right part now. We have 3. uh, we'll check. We are considering 3 directly because we don't have the left node here. We don't have the left node here, right? So next we'll go with the 8. For the 8 we have the left node here, 9 and then 8, right? So we don't have the right node here, so be null. So this would be 1 comma 3 comma 9 comma 8 here. So the output for the this one second example would be 4 2 6 5 7 1 3 9 8, right? So this is what we'll be doing basically. This is the what do we call, this is in order traversal basically, right? So this is fine. For the third example we don't have any elements within the root, so the output will be empty. So the fourth one we have only one element, so we have to return the same thing, right? So I hope this part is completely clear. Let's come to the approach. Let's consider the first example here. Let's consider the first example. We have 1 null 2 and 3. So here what we will do, we will start with the root 1, right? We will start with the root 1. This one I'm speaking of root. We'll start with the root 1. We'll push this one to the stack. We will push this one to the stack, right? uh, we'll go left. No left here. We'll go left. No left here. So we will pop 1. We will pop 1 and we will add that one to the result. So now we have 1 in the stack. Now we have 1 in the stack. Now we will move to the right. we have the value 2 here. We have already considered 1 here, so now we have 2. So um, we will push 2 to the stack. So we will go to left. We'll go to left. We have 3. We will go to left. We have 3. Right. Then again, we'll push that one to the stack. So here we don't have now. We are not left with anything. We don't have left. So we will pop 3 as well. We will pop 3 as well. But 3 is the leaf node, right? We don't have any element under it. So we will pop 3 as well. So the output will be now 1 comma 3, 1 comma 3. So next we got 1 comma 3. Now 3 has no right, 3 has no right as well, right? So we will pop 2 and we will add that one to the result. We'll pop 2 and we'll add that one to the result. So now the resulting array consists of this one 1 3 2. So 2 has no right, 2 has here this one, 2 has no right, it is null. So we are done, we are completely done, right? So the final output here that we got here is this one 1 3 2, 1 3 2. So this is the approach that we will be going with. This is the approach that we will be going with for this particular problem, right? So mainly we'll be making use of the stacks here. Mainly we'll be making use of the stacks here. So I hope the approach part is completely clear. As we are done with the approach part, let's quickly discuss the complexities and then let's write the code. So what will be the time complexity? So the time complexity would be big of big of n. So why it is big of n here? So we are visiting the each node once. We are visiting the each node once. So the time complexity would be big of n. And what would be the space complexity here? The space complexity would be big of n as well, big of h. So we have to consider the this for the skew tree or the worst. In the worst case, we'll be considering the skew tree, right? So here h is height of the tree. Due to the stack, worst case would be big of n for the skewed tree. We can either consider big of h or big of n. I'll just go with the big of because h is nothing but the height of the tree. In the worst case, we'll be considering for the skewed tree. So you can directly consider big of h itself rather than big of n. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of h. So as we are completely familiar with the approach and the code, let's start writing the code. We are good to write the code now. Let's start writing the code. First, let's go with the array list to store the final in order traversal. So I'll just go with here list of integer. This one will be result equals new array list, new array list. So this is the only thing. Next, we have to go with the stack, right? So we will be going with the stack here. Basically we are making use of it to simulate the recursion stack. So we are going with the stack with iteration. So I'll just go with the stack, this one tree node. Let's go with the variable name stack. This one will be new stack. This is fine. So the next step here would be we have to start with the root node, nothing but here tree node. So this will be current equals root root. This is fine. So the next step would be here. Let's go with the while condition here. Current should not be equal to null and stack shouldn't be empty. Then only we can move forward, right? Move forward with the further steps or move on with the next step. So here this would be current not equal to null or this one out of stack dot is empty. We're just making use of the is empty operation that is provided by the stack. So the first step is we have to traverse this one left subtree first. Left subtree first, as we have to go with the in-order traversal. In-order traversal is of the order left node then right, right? So we will be traversing left subtree first. So let's go with the while loop, simple while condition here, while loop. So this will be while current not equal to null, then within the while we have to push the current node and we have to move to the left child, nothing but here stack dot push. As we are going with the iteration, a bit of lengthy code. If you would have went with the recursion, it would have been easier one. So this is fine. We can just go with stack dot push of current. So the next part is we have to move to the left child. Means here this would be current equals current dot left. Current equals current dot left. This is fine. So this has to be n, not m. So yeah, let me come out of this while loop. So next step is we have to pop from the stack nothing but the leftmost node accordingly with the approach. So here let me copy this one, current equals stack dot pop. This is fine. Stack dot pop. The next step is after popping from the stack, we have to process the node value, nothing but in order traversal. So here, so let's go with result dot add of this one, current dot value, right? So I'll just go with current dot val we have considered for the value, right? So this is fine. uh, just give me a second here. Did I miss anything? No, right? So value, this is fine. Now we have to process the right subtree, meaning I'll just copy the current here, this one, current dot right. So we are just processing the right subtree. We are done, almost we are done with the code. The only step is we have to return the result, right? So we have to return the result finally. So this is it for the code. Let me format the code once and let me hit the run button. So here you can clearly see the sample test cases are getting passed. Means the code works absolutely correct on this case. The code works absolutely correct on this case, right? Let me hit the submit button quickly. So I hope this works for all the test cases, man. Let's see. You can clearly see here the code works absolutely correct for all the test cases, right? So I hope the solution part is completely clear along with the complexities and the approach. For now, this is it. Thanks for watching, guys.